So guys, the toolchain to be used for our ARM Cortex-M based project is the ARM non-eabi GCC toolchain. This is the GNU GCC version for ARM. GNU GCC actually can be compiled as a toolchain for different architecture and hardware and processors. Means we can have a GCC version for RISC-V, a GCC version for x86 based processor, a GCC version for MIPS, a GCC version for ARM Cortex-M, and so on. So here it depends which option has been provided during the compilation of, or what is called cross-compilation of the GCC sources. In our case, the GCC actually repo was compiled for ARM Cortex-M, and the outcome is this ARM non-eabi GCC toolchain. So after the installation of this toolchain or dependency package as part of the previous section, the outcome will be this folder. And here we have subdirectories, but the one that we are interested into it will be this bin directory. This one will contain set of tools which includes actually the compiler, linker, assembler, and many other helpers tool. Now for any new toolchain, the first thing actually to identify is the compiler, because this is needed to compile the different C sources with extension .c. For the GCC, and by the way this is applicable as well for the GCC toolchain for RISC-V, for x86 and so on, the tool to be used to compile the .c files is this GCC. For ARM, this have this prefix ARM non-eabi GCC. If we are going to do some assembling, it means we are going to compile right away the .s files, then we can use this ARM non-eabi ASM. This one will accept any file that has the extension .s. However, for GCC, there is a very good option is that we can provide as well the .s directly to the ARM non-eabi GCC. Then you may ask yourself what's gonna be the difference here. The major difference is that for the GCC, we will be able to parse the .s file, and if there are some if-defs there or some pre-processing stuff to be done, then the GCC will be able to do it and recognize those if-defs. If we'll try to do the same, we provide the same .s file with the same actually pre-processing things, macros, or those if-defs, then this ASM tool actually will recognize those as an errors and then will stop the compilation. So here it depends really from the structure of your .s file. Now after we recognize the compiler, the assembling tools, now it's coming basically the linker. For the GCC we have what is called LD. Here it is ARM non-eabi LD. Again, this is only for GCC. We can use as well the ARM non-eabi GCC as front end for our linking stage. It means we can provide the different linker options as well as the linker script to ARM non-eabi GCC. Then that one will do some pre-processing for the linker script as well as for some other inputs file. Maybe we include basically some headers file, and then we'll provide the option and the outcome of the pre-processing stage for those files to the linker.ld, which will be kind of back-end tool then, and this one will do the real linking to generate the final .l file. So it means we can use actually this ARM non-eabi GCC for compiling, assembling, pre-processing of course, and linking, all within a single tool. Besides those, those elements, which are the basics one actually to compile and generate our ELF file, we may have some set of helpers tools, as we have seen in previous slides and sections, like to generate the disassembly file using the object dumps. This is ARM non-eabi object dump. We have as well the object copy, which allow modifying and updating basically the generated .elf as well as the object files, and doing the conversion of the .elf to the .bin, for instance. We have the size to generate basically the memory conceptions in terms of sizes for different objects file and elf file. We have the strip. It will allow stripping different metadata and symbols out of the .elf. and this is actually useful mostly for libraries. So we can generate .a library without linking, and there we can use the strip actually tool to strip out any metadata and symbols from this library to have only pure binary there. The nm tool will allow us to generate the list of symbols with their corresponding address as that exists within the ELF file. And of course we have this one for GDB. This is the GDB client. So if we are having a debug session, we need a GDB server. This can be, I don't know, G-Link GDB server, OpenOCD, and so on. However, we need as well what is called GDB client to communicate with this server. And here the GCC toolchain provides this GDB client. We have other tools, of course, but what I have stated are the most important part for the embedded C project. If you are having another project like C++ projects, GCC offers the tool actually to compile the C++ project, but in our case we are interested only on the tool needed to compile our embedded C project and to do like post-processing of the generated ELF file. So guys, this was an overview about the toolchain to be used as part of our project.